Okay, here we go. Chapter 3.1, Decimals and Estimation. I have a feeling that this won't be too tough for you guys. You're ready for this stuff. This is similar to things that you've done last year, but we'll just jump right in. We're going to talk about estimating a decimal sum. So we're going to estimate a decimal sum. Remember, a sum is addition. And imagine that you're grocery shopping and you buy something for you buy a bunch of things. You got something for $2.52, $1.99, $2.98, $3.78, $4.15, $5.11. Now I'm kind of not writing in a very straight line. This is the tenths place, tenths of a dollar. Those should be lined up, and this is the hundredths place, hundredths of a dollar. Those should be lined up too. So if I'll try to be more careful, you try to be more careful when you do it also. Some of you guys just do fine, but it's easy to make a mistake. Okay, so if we're going to add the sum, we would just go ahead and start adding over here. And we'll do that, but before that we're going to estimate the sum. So we're going to bring all of these numbers over as estimates. And we're just going to round, just basic rounding. So 252 rounds up to $3. $1.99 is 2, $2.98 is 3, $3.78 is 4, $4.15 is 4, $5.11 is 5, and $6.59 is 7. And we add those up. 3 plus 2 is 5, plus 3 is 8, plus 4 is 12, plus 4 is 16, plus 5 is 21, plus 7 is 28. I might want to check that. Check it twice to make sure I do it right. 2, 6, 6, 7, 8, 12, 16. It looks like I'm getting the same answers all the way through. Okay, so this is what I come up with my estimate. And this is what your estimate if you're showing your work. That's what it might look like. Okay, and if I went ahead and I went back to actually adding, this is kind of, is a lot of numbers. 11 plus 8 is 19, plus 8 is 27, 32, 33, 42. So this is 42. And I carry that over to the tenths place. 9 and 9 is 18, and 9 is 27, and 7 is 34, 35, 36, 41. Hopefully I'm doing it right. You guys catch me if I make a mistake. The decimal comes straight down. 6, 7, 8, 9, 10, 11, 12, 16, 21, 27. $27.12. We got 28. Now if we were to round $27.12, we would round down to 27. But when you're estimating, you're not supposed to find the actual answer and then round. You're supposed to round all of the components and then add because it's easier. You might get something slightly off, but it's close enough to be reasonable. And that's important. Reasonableness is nice to have. Okay, that's estimating. A sum. We're going to look at products and quotients. Product, remember, is multiplication, and quotient is division. So the first thing to do would be round to the nearest whole. So one way is to round. And if we took the number 12.3 times 4.8, this would round to 12 times 5. And 12 times 5 is 60. 10 times 5 is 50, plus 2 times 5 is 10. That's 50 plus 10 is 60. Okay, and then for a quotient, 62.9 divided by 7.48, 7 48 hundredths. And this would round to 63 divided by 7, which would equal 9. Okay, 62.9 rounds up to 63 to the nearest whole number, and 7.48, 7 48 hundredths rounds down to 7. That's the nearest whole number. And 7 goes into 63 nicely. All right, so this is important when we're rounding. The numbers need to work. but sometimes the numbers don't work, and I'm going to show you why we use compatible numbers. We're going to do the same thing, but we're going to use compatible numbers. And they are compatible because they go together. And that's probably the best way to describe them. They go together, they are compatible. Now these are almost the same numbers as the ones we just did, but they don't work as well. 48.97 divided by, multiplied by 3.91, 3 and 91/100ths. Okay, if we were to round this, we're not going to, but if we were to round this, this would round up to 49 times 4. And we could do that. It's really not that complicated. 40 times 4 is 160, and 9 times 4 is 36. And we'd add that together, 196, or something like that. But we want to use compatible numbers. Numbers that work together would be things that we can easily do on our head, like 50 times 4 is 200. So 3.91, we just rounded up to 4. But 48.97, instead of rounding up to 49, we rounded it all the way up to 50 because it works nicely. And that's called a compatible number. It works really well. And for division, it's even more important to use compatible numbers. 62.9. Sorry, 62 point, that's the one we used last time. 62.45 divided by 11.72. And this time, if we were to round, we would round to 62 divided by 12. And 12 doesn't go into 62. It doesn't work. So we want to use a compatible number. We're going to leave 12 alone. But we're going to round 62 into something that 12 goes into. And 12 goes into 60 nicely. So we're going to divide 60 divided by 12, which is 5. And that is a compatible number. This one doesn't work. We'd have to do long division or get out a calculator. Here we have an easy answer, around 5 times. So we could use a compatible number to find an estimate for this division problem for this quotient. So we're still estimating. Okay, that's it. That's all I had to show you. Stay tuned if you want to see my friend Fred, who is spending some time thinking. He has to really think hard. So here's Fred has kind of googly eyes, and these are his thinking eyebrows. He doesn't have a peanut-shaped head. It's sort of a mango-shaped head. There he is. And then, oh, his nose is bigger than that. Oh, that does not look like Fred. There's Fred's nose. And then this is his thinking smile, because he's kind of smirking on one side. He's concentrating really hard. Now, the interesting thing about Fred is he has crazy hair. This is Fred's hair. And these are Fred's ears. And I wanted you to know something else about Fred. He has no neck to speak of. And sometimes, you know, when he's thinking really hard, he makes he puts his finger up to his chin. See, like this. And you can see that he has no neck. It makes it really clear when that happens. But sometimes he gets an idea, and he puts one finger way up in the air. Boy, he has long arms. And the other thing that's kind of fun about him is he always wears bell-bottom pants. So they're really wide, and he's got black shoes. There we go. And let's see. I'm not sure what color his shirt is. But he's got a purple belt. And that's cool Fred. His name is Fred. All right, have a nice day.